Today's notes are domain and range of continuous graph. In class, we already talked about domain and range of discrete graphs. So let's review what a discrete graph is. Discrete graphs are unconnected. For example, if I have 3 points that are not connected, this is discrete. There are no type of line connecting these 3 points. Okay, the domain and range would be 3 separate numbers. Okay, continuous is different. So continuous graphs, they are connected. They are made up of many points. So if it has any type of line, so if it's a solid line, a wavy line, a line that has arrows, a line that has a stopping point, that is continuous. So continuous lines are set up like this. Continuous domain and ranges. So X is for Y. The smallest X value goes here. The largest X value goes here. The smallest Y value goes here. The largest Y value goes here. Okay, we always use less than because we're going from least to greatest, So it has to be less than. We never write them greatest to least. So the less than part never changes, but sometimes it is less than or equal to. If there is a solid line, like on this graph, we use less than or equal to. If it's an open circle, we use just less than. So smallest X value, largest X value. Smallest Y value, largest X value, what goes here. All right, let's do some examples. For a domain, scan your pencil left to right along the x-axis. So let's do this example. We're going to go left to right. Left. I like to circle what's on the left side. Right. So what's on the left side? There's an arrow to the left side. To the left side of the x-axis are the negative numbers. So they go on forever. So if it goes on forever in the negative direction, that's negative infinity. Scan to the right. There's another arrow. On the right side of the x-axis are the positive numbers. It goes right forever towards the positive numbers. So there's going to be a positive infinity. So these are the two endpoints. The smallest X value, the largest X value. So remember how to set them up. The smallest X value, the largest X value. Okay, for arrows, we don't use the equal to, we just use less than. Okay, range, scan your pencil, bottom to top along the y-axis. So bottom, so at the bottom, there's no arrows at the bottom of the graph. The lowest y value is -1, -2. the highest y value. If I scan the largest value, is an arrow. It goes up forever. So the smallest is -2. The largest is infinity, positive infinity, because it goes up forever. So remember how to set up the range. Smallest y value is less than y is less than positive infinity. So if there's a number, we're going to use the equal to, because it actually does go through -2. If you have a number, the only time it doesn't have an equal to sign under it is if it has the open circle like this. So with examples like this, if it's multiple choice, you will not see the answer being left like this, because they will never have a number and an infinity sign. How they would write that? Y values are greater than or equal to -2. They get rid of this part because we don't need the infinity. So how I think of it, if the arrows are going up, then it's going to be greater than. If the arrows are pointing down, it's going to be less than. It has one limit, one number that it stops at, and then one arrow. So whenever your domain or range has one number that it stops at, but one arrow, it's going to be written like this. You can start off doing it like this, but once you realize there's a number in an infinity, you need to fix it. So if you start off like this, your variable has to be first, so I can switch the variable and the number. Because I switch the variable and the number, I have to switch the inequality symbol. So this is what I want to see, not this. All right, number 2, domain, left to right. So if I scan left, this circle stops at -1, -2, -3. Scan right, it stops at +3. So the domain is from -3 to +3. Because these are numbers, we use the equal to. Okay, range. The lowest y value is -3. The highest y value is +3. So it's from -3 to +3. That one was pretty easy. Okay, number 3, range. Scan left. To the left, I have an arrow. That means negative infinity. To the right, I have another arrow. That means positive infinity. So our lowest x value is negative infinity. Our highest x value is positive infinity. Range, bottom to top. So the lowest point on this line, there's an arrow. So that's going to be negative infinity. The highest y value, there's another arrow. So that means positive infinity. So whenever you have arrows going in both directions, it's going to be negative infinity to positive infinity. So if you have an arrow left, an arrow right, that's negative infinity to positive infinity. If you have an arrow from bottom to top, that's negative infinity to positive infinity. Okay. For domain, we scan left to right. So left side, I have an arrow. Right side, I have an arrow. What does that mean? So an arrow to the left means negative infinity. Arrow to the right means positive infinity. Range, we scan bottom to top. So if I scan the bottom, I have 2 arrows. If I scan the top, it stops. It doesn't go up forever. It stops at 1, 2, 3, 4. So at the bottom, it goes down forever, so that's negative infinity. The top, it stops at 4. So I have a number and I have an infinity sign. That's kind of like the example that we did on number 1. So we're not going to write it like this. We're going to write it like this. So the y values, and then the one number I have is 4. So are the y values greater than 4? Or are all these values on the graph less than 4? Well, the arrows are going down. So all the y values are less than or equal to 4.